Welcome back to my channel. Today we will start our video with a quote from Arthur Stanley Eddington. Arthur Stanley Eddington, those who don't know about him, he was the one who actually proved the general relativity. Though Einstein proposed theory of relativity, general theory of relativity in 1916, in 1905, he proposed special theory of relativity, and in 1916, he came up with general relativity. And but, however great the theory was, there was no practical proof, and there were many skeptics who did not think it was correct. They wanted proof. So, what Sir Arthur Stanley Eddington did was he went to some place like Hawaii or somewhere, and what he did was he photographed sun during a solar eclipse, and when they looked at the photographs, eclipsed sun, they found the stars in a different position, meaning the light coming from here, it basically bent. It was straight. Earlier it was straight. Now it was bent, and it was showing the stars in different positions than expected. Expected in the sense when you have normals. So that kind of proved that gravity bent light. That was a proof he came up with, and rest is history, as we say. And the same Eddington uh, wrote a book on theory of relativity, the theory of relativity by Arthur Eddington. You can find it anywhere in all the famous publication houses. You will find it. So what he said was, same Arthur Eddington, matter does not cause the curvature of space-time. Space-time it is the curvature. That's what he said. And then, just as light does not cause electromagnetic oscillations, but oscillations itself. It is the oscillations. It is the oscillations. But it is the oscillation. Actually, it also itself. So this is the famous quote by Arthur S. Eddington, who proved the GR theory. Right? So uh, that inspired me a lot. In fact, to come up with my own theory. So now let us start understanding my theory in view of Eddington's comments. Keeping his comments in view, let us see what my theory can be depicted as. Okay, now, last time when I was explaining uh, the particle versus wave nature, I was a bit confused and I abruptly ended the video because uh, I did not know which to call the wave and which to call the particle there. So I thought it over. Let's say, let us take a line segment of magnitude 10 squared. This is basically the first, you can as well say this is 2r, 2r in circular terms, and this is the side L, let's say, if you take the cubical architecture. So if this is 10 square, this whole square will be 10 raised to 4, right? 10 raised to square is 10 raised to 4, and you have the third dimension. What will be the third dimension? Third dimension will be basically this whole thing, meaning 10 raised to 6, 10 square, whole raised to cube. In basically what we call the 10 raised to 4 will be pi r squared. This is 2r. This is pi r squared. This is 4/3 pi r cube. Right? When we take the sphere, cubically it is 10 raised to 6. So we are clubbing both. Uh, we are taking basically the circle, then we are taking the surface area of circle, then we are taking the volume of circle. This is volume. In cubical terms, volume is 10 raised to 6. Side is, this is side is 10 raised to 10 square. Similarly, we have 4 pi r square also. 4 pi r square, what is the equivalent of 4 pi r square? 4 pi r square is the surface area of the sphere. What will be the equivalent surface area of a cube? Cube will be 6 into 10 raised to 4. Right? This is one face. This is one face. This is one face. That is one face. That is one face. This is the last face. So 6 faces it has, and 6 into 10 raised to 4. These are the equivalent terms. So now we have this. Whenever we say a particle should be three-dimensional. Right? Particle, an ideal particle would have 3 dimensions. So these 3 dimensions, this sphere as well as this cube represent the third dimension. How we got there? We took pi, we integrated, we got pi r, we took 2 into such pi r's, integrated, we got pi r squared, 2 into by 2, by leaving pi r squared. We took 4 into such pi r squares areas, and we got 4 pi r cube by 3 volume, and we took 6 into such a 4/3 pi r cubes. dr is equal to 2 into, let's say, is 2 times. This is not 2 into pi or 4 by 4. So that 4 and this 4 cancel. Let's just keep that 4. 4 is 2 times. So 2 into this. So this 4 get cancelled. The remaining thing is 2 pi r. So we started with 2 pi r. We at first dimension. When we came to fourth dimension, it became 2 pi r or 2 pi r 4, the fourth dimensional radius. Right? That's the basically what we discussed is about quantum world, quantum reality. Now we have relative reality. Let us look at. Same thing we do. Take this time. What we do is we take C. Right? We take C. What is C now? This C, if you take this cube, if you consider this as a particle, and if you take one more 10 squared here and take what do you call uh, uh, vector product 10 square. So the magnitude becomes 10 square into 10 raised to 6, that is equal to 10 raised to 8 at the 2 pi r 4 stage. Right? It's not just 10 raised to 8 is a straight figure we got. We have to take 3 of them. 3 into 10 raised to 8 is the electromagnetic wave. Right? This electromagnetic wave will now become the what do you call first dimension. Similarly, whatever we did here, c squared we take, and then we take and this will become c cube volume. First is 2 pi r, then pi r square, then the sphere itself. Sphere here. Now let us do the same with this pi r. We took pi r, and what is equivalent of pi r is 2r. Right? Here we have 2r. This is a pi r square, right? Here 2r whole square, 2r whole cube, 2r whole raised to 4. That will be the value of corresponding value of this being spherical, this being cubic. So these are the equivalents. So now taking similar C here, again one more C, and taking the cross product, what will you get? C into C cube equal to C4. Right? So does it sound familiar? C4. But the only problem here is that following this architecture, the final product was 10 raised to 8. Here, the final product is C raised to 4, let's say. And this we need 3 into 10 raised to 8 here if you want to implement C as the basic uh, unit here. We can consider C as basic unit, so we need 3 into 10 raised to 8. Getting 3 such things here is a problem. That is the only thing we need to bother about. And now, so yeah, that unification will come to the unification later, but for now we will see what this could mean. Not for nothing, I took 10 square as the starting point and built up to see the speed of light, the speed of electromagnetic radiation. Not for nothing, there's a whole lot of meaning. Mm, yeah, and then now let us go to the best scientist, I mean, one of the best scientists we had, apart from Newton, Einstein, and all those greats, Carl Gauss. Carl Gauss gave us the Gauss law of gravitation, law of electricity, even law of magnetism. He was one of the most intuitive scientists ever lived. So, what he came up with is what he said about the law of gravitation is, let's say, if we can use phi g, let's say, phi g is flux of gravity field is proportional to mass mass of the mass in the enclosed surface. Okay, and similarly, I mean they are similar. That's why I'm continuing with this. Let us go to the law itself later. Law of electricity is a rho by epsilon naught. That is, the flux of electricity is proportional to the charge. Now, uh, magnetism is of course this is Gauss law itself. Is it uh, if you have a magnet, the lines come go out. So this lines coming in, lines in are equal to lines out. So there is no net flux. Okay, that's what he told about the magnetic flux. Now that actually these two are the first two laws of uh, Max Maxwell's laws, right? So the thing is, the Gauss law of electricity, that is rho by flux is given by rho by epsilon naught, can be derived from Coulomb's law. Another great scientist, Coulomb, Coulomb's law. What does Coulomb's law say? The electric force is equal to, I'm using my own symbol here. Electric force is equal to 1 by 4 pi epsilon naught q, um, q1 q2 by r square, where epsilon naught is equal to 4 pi into 10 raised to minus 7 units. I don't know right now. So the 4 pi into 10 raised to minus 7 is epsilon naught, and he said 4 pi epsilon naught q1 q2 by r square. You can rearrange this into 4 pi r square into q1 q2 by epsilon naught. Okay? So what do you see here? What did he say? What Gauss said about electricity? He said the electric flux is equal to is proportional to Q contained in the closed surface, right? So when we look at this, what immediately should come to our mind? This part, the denominator, 4 pi r square is surface area of sphere. Right? Now, Remember this 4 pi r squared here. So the charge which is distributed over the surface area of sphere gives you the flux, electric flux. That's the what do you call the gist, bottom line. Now, now we go to the next part. The derivation involves Dirac's delta function. Using Dirac's delta function, you can basically derive Gauss law from Coulomb's law. Right? Now, now we'll try to uh, we'll see what happens to gravitation. Now, as I told you, it is a Gauss law for Gauss law for electricity. We could derive from Coulomb's law. Now we will turn to gravitation. What is Newton's law? Newton's law of gravitation is the gravitational force, let's say my gravitational unit, is equal to Gml by r square, right? Where r, where r is the distance and m is mass of bigger object, let's say, and m is mass of smaller, right? So now we all know Newton's law of gravitation, just like that. But I came up to came up with we just now we saw that epsilon naught is equal to 4 into 10 raised to minus 7. Uh, I I was doing some research and the gravitational constant is given by 6.67 into 10 raised to minus 11. What the way I got this idea was the equivalent of the same thing we already saw that not flux, the electrical force is equal to 1 by 4 pi epsilon naught q1 q2 by r square. Yes, now we saw that. If you compare these two, we have 4 pi epsilon naught here, here we have g. So I thought, why not convert g into 4 pi epsilon naught, I mean in terms of 4 pi epsilon naught, and see what we will get. To my surprise, what I got was 1 by 119 into 4 pi into 10 raised to minus 7. If you take, this was exactly little less, approximately equal to g into 10 raised to minus 11. See how wonderful it is. This can also be, in that means, this can also be written as 1 by 4 pi um, uh, um, into 190 into 10 raised to, basically there it is 10 raised to minus 7 here, epsilon naught. Our term here, let us epsilon with let us say zeta, let us say zeta, zeta naught, I will call it. Gamma is equivalent for G. Anyway, for now, we will call it zeta naught. Zeta naught is, instead of minus 7, I got plus 7, and the extra term was 190. So you can as well express this formula for inertial gravitation as 1 by 4 pi 4 pi, and this you can call zeta naught, let us say, and by r square. So how similar this and this are? If you call this whole thing one thing, like epsilon is zeta naught or whatever, 1 by 4 pi epsilon naught, 1 by 4 pi epsilon zeta naught, q1 q2 by r square by r square. So we have found a new correlation between g, the universal gravitational constant, and the epsilon naught. In terms of epsilon naught also, we can define g. So that was one discovery I made. And then we'll go to next chapter. Now, what now we'll try to build correlate these arbitrary magnitudes that we took, 10 square, for example. C is no arbitrary value. We know C, well known constant. So for C, I need not explain, but for 10 raised to 2, and the other thing is, I started explaining which is particle and which could be particle and which could be wave. That's where we started, and we are back to the same subject. So now this 10 square we took, the square's area was 10 raised to 4. Yeah, we write 2 pi r, or this is area is pi r square, and 4/3 pi r cube. Okay. So all this, and we'll talk about the feasibility of this, whether we can take a vector product of this and with 10 raised to 6, this is 10 raised to 6. So 10 raised to 6, 10 raised to 2, giving 10 raised to 8. And if you take 3 such objects, this represents the photon, photon in the sense of light. So, yeah, we took light. So here, when we take this, generally how an electromagnetic wave is predicted as this is like this is like this. They are at right angles. These parts are at right angles, meaning one is magnetism, the other is electricity. If you take right hand rule, this is magnetism, this is electricity, this is the direction of movement of the field, direction of field. Let's say electromagnetic waves, direction of electromagnetic waves. Right? So, these, and we also saw the other day that double in the double slit experiment, we got interference. This was interference, meaning it is both particle, light is both particle plus wave. So, which is wave here? If you consider this as wave, magnetism as wave, this as particle here. What are the corresponding parts here? Let's say if you take this 10 square and this whole cube or sphere, that whole thing has electricity, meaning 10 raised to 6 is electricity, 10 raised to 2 is magnetism. These are at right angles. One is particle, the other is wave. Combined together, they are again. This is 3 into 10. Right? You can visualize like this. And the yeah, uh, that's about the basically quantum theory. Quantum, yeah, this is. So let us now go to again. Let us go back to the our world in the sense the physical relative world. Right. Now we'll go to the relative world again. Do the very same thing. This is C. This is C square. This whole thing is C cube. Similarly, we have a sphere. The whole thing is a sphere, a particle, and this particle will take one more C here. Cross product, take cross product. This will be C into C3 equal to C4. This is there. We called it. We already have a name for the quantum field, quantum entity. That was the electromagnetic radiation. Now I call this the photon EM radiation or electromagnetic radiation. Meaning, I have included graviton, photon. I mean, I'll come to that. Why I did that? Why I named it like that? We know Gauss law says that the flux of gravity is proportional to mass. Mass contained in the closed surface. Right? So, if you take this, this is C, this is light, right? And this whole thing, we have already observed that the flux of gravity is equal to 1 by 4 pi something naught, zeta naught something into uh, g, instead of g we took the mm by r square. So if you take this r squared and club this with 4 pi r, what will you get? You will get the surface area of the sphere. Surface area of the sphere is 4 pi r square. So this r square, this 4 pi, this is 4 pi r square. This basically it represents either 4 pi r square or 6 into, if you take um, c 6 into c square, right? 6, what do you call it? 1, 2, 3, 4, 5, 6. 6 surfaces, each of uh, magnitude c square. So c 6 c square or 4 pi r square, right? This 4 pi r square, if you remember, and then it is nothing but flux of gravity. And what did he say? Proportional to mass. This is mass. The whole thing contained in this solid sphere and the cube, the whole actually solid sphere, because sphere's property is 4 pi r square surface area. So this mass contained in sphere divided by 4 pi r square, mass contained divided by 4 pi r square gives you the right of flux of gravity, right? So that's I hope that um, uh, you you understood what I explained just now. I hope, and then we will go to the next one. So here we have basically mapped magnet 210 square with magnetism, 10 raised to 6 with electricity, 10 raised to 8 with photon. I mean photon in the sense light, right? That part is clear, very clear. Similarly, 3 into 10 raised to square, the first dimension. Let us go to it. So when we say 4 pi r square. This 4 pi r square, the mass contained in the sphere divided by 4 pi r square, what should it give you? Right? Uh, that should give you gravity, flux of gravity. Similarly, there is what is called 10 square, 10 raised to 4, 10 raised to 6. This whole sphere we took, we take whole spheres missing is 10 raised to 6. 10 raised to 6 by 4 pi r square, let's say, should give you, yeah, so this is magnetism. We already attached the tag. This whole thing, we called it electricity. The sphere itself, whole sphere, and we took another magnetism, magneton, I call it, 10 square again, and we got 10 raised to 8. So what should we call this 10 raised to 4? 10 raised to 4. By analogy, here it was, the whole thing was gravity, gravity, the whole thing is c cube gravity divided by 4 pi r square, we got gravitational flux. Here, similarly, what is that? Sorry, mass, mass, mass by 4 pi r square gave you gravitational gravity, flux of gravity, flux of electricity was given by 1 pi 4 pi epsilon naught q by r square, right? Let's say this 4 pi and this r it left, and again here that 4 pi r square. We are dividing the charge with so what should this 10 this should be, this whole thing is electricity, and 10 raised to 4, this 10 raised to 4 would be the charge. Rather, one second. These two very confusing things. One is we have mass and gravity. We have charge. Charge is the cubical part or sphere part, and gravity. Instead of gravity, we have the flux. This flux will be given by 4 pi dividing charge with this. So this will be the flux. This will be the gravitational flux. So we are good as far as this is concerned. I hope you have perfect mappings, magnetism, electricity. Here we have light, gravity, and flux. Flux is always 10 raised to 4 or 4 pi r squared. Whatever is divided by 4 pi r squared is the flux. We here also divided by 4 pi r squared is the flux. This is electricity. This is magnetism. Right? C C4 C4. So we are the most important uh, number, or what do we call, field is this C4 in whole of relativity. Why? Why 4 is the most significant? C4. C4 is the most significant because Einstein used 8 pi g by C4. Curvature, the curvature tensor is the energy tensor. Right? To get energy tensor, we multiplied curvature tensor, we multiplied energy tensor with 8 pi g by C4. C raised to 4. That's why this C raised to 4 is the topmost of what you call the Einsteinian world. So basically, he thought everything is included in C4 so that he can get the curvature by dividing the energy, whole energy contained in the system by C4. Right now the problem comes, the biggest problem of all. Earlier, I told you while explaining the Pascal's triangle, I said this is a root C, fourth root C squared, C cubed, C4. And I said C5, C6. I said we have to go till here, C6, to come up with tau. But as I have always been telling you, the only flaw of the relativity is that we took just 4 by 4, 4 by 4 matrix. Instead, I said we have to take 7 by 7 to include 6 dimensions. So, if you count from here, it is 1, 2, 3, 4, 5, 6, 7, 8. Right? So, the relativity in itself is quite okay. It is combining, the only flaw being here, it is combining only this part, C4. Right? What we need is we should combine these two ideas. Those two are basically from here it is the quantum world, this is the relative world. So what we need to do to unify we should consider the same thing in a 3, 4, 5, 6, 7. I ask you to consider these two. So let's say root C, fourth root C squared, C cubed, C4, C5, uh, and also one more C6, one more C7. We have to come go till here. I told you But the thing is, we should keep to this only. That is, that will give you this included. This is quantum. From here, from C onwards, it is relative. So to unify both, you don't need to move beyond C4. You can, but the the secret here is don't mind my drawing all the time the same uh, structure because that is very difficult to understand. This is the quantum one, quantum real, relative real. With this, we add one more 3 here. This is C3 and C4. We get C4. C4 is C4 and C4 is gravito, photo, electromagnetic radiation. Wave, right, wave. Meaning it breaks here. It breaks at C square, C cube, C4. Here it is 10 raised to 8, 10 raised to 6, 10 raised to 4, 10 square. Starting from 10 square, you can build this is you can build C from this. If you take 2 pi r 4, fourth or n raised to 4, fourth dimensional, fourth dimensional cube or equal cube or sphere. If you take, if you go there, you will get this. And after that, this is square, this is cube, and the C cube again, and one more C. If you take, you get C4, which which completes the unification. So I would say the unified real is gravito, photo, electromagnetic radiation. It it splits into this. If from our real world, this is where the split occurs. This is quantum. This is so. This is quite simple. I think quite plausible. Very much, very smooth, uh, smooth integration or unification is possible. I, as I told you in the very first video, I am not much of a mathematician. I don't know what math to apply here. I'm still learning. So once I learn, probably I may come up with a proper way to implement these two. But meanwhile, uh, anyone who wants to collaborate with me or um, work on seven dimensional, this seven dimensional, these three dimensions are from quantum world. The fourth dimension of quantum world is the third dimension of relative world, and this three, four, five, six, seven, seven will be this C4. C4 itself will be the what do you call you can call this this is the time of fourth dimension of quantum world is time of this three-dimensional Minkowski space. This space is Minkowski space. This world is relative space. Yes. This C4 is the time, the time-like magnitude. The C4 is time-like, that is time-like, that time-like, and these three plus these four all together will make seven dimensions, one time-like, C4 itself, six space-like, this plus this. So our task is to combine this whole thing. We can combine that will give you the perfect unification. Thank you very much. It's been very long. I will call it a day for now, and we'll continue sometime, some other time. I hope you uh, got something to learn in this video, and if you like, share, subscribe, and comment. Thank you. Thank you very much.